Hi everyone, so here are your notes for 9.2 special right triangles. So the first triangle we're going to talk about is the 45-45-90 triangle. Now it is of course called the 45-45-90 triangle because it has two 45-degree angles and of course one 90-degree angle. So this is how we identify it. Now one other thing I want to note is the fact that the 45-45-90 triangle is, yes, it is a right triangle because it has a right angle, but it is also an isosceles triangle because it has two angles that are congruent, which also means that I have two sides that are congruent as well. So just keep that in mind. All right, now in a 45-45-90 triangle, the hypotenuse is the square root of 2 times as long as each leg. Now I know this sentence looks a little bit weird, but if I were to say that the hypotenuse is 3 times as long, or if the hypotenuse is 4 times as long, we know what that means. This is the same idea. It's just it's not a whole number. The hypotenuse is square root of 2 times as long as each leg. All right, so these are parts on the right triangle. Let's go ahead and quickly identify them. The hypotenuse is the side that is always across from your 90-degree angle. And I'm going to label that side with H for hypotenuse. So H is my hypotenuse, HYP for short. And of course, the other two sides, which are congruent, I'm going to label those as L. And L just quite simply stands for legs. Okay. Now, as for the equation, it says that the hypotenuse is the square root of 2 times as long as each leg. So, the equation here is H is equal to L times the square root of 2. Yes, you could technically write this in a different order, but I like having the variable or this number in front of the square root of 2 so that I don't get confused and accidentally put it inside. Okay. All right, let's go ahead and let's actually now use this in an example. All right, so here is example 1. It's asking us to solve for the missing sides. Notice how there is more than one missing side in this triangle. They want us to give an exact answer. All right, so first things first, looking at this triangle. It's so important that we always identify the triangle first. I know it seems a little obvious, but when you're faced with multiple different triangles, sometimes we forget to think about what kind of triangle we're working with. So we need to always identify your triangle first. In this case, it is a 45, 45, 90 triangle. And then if I know that I have a 45, 45, 90 triangle, then I'm going to immediately, right away, write down the equation that is associated with the 45, 45, 90 triangle, which is H is equal to L times the square root of 2. Now I go ahead and come back to my triangle and take a look and see what parts do I have that are given and which parts are not given, which I need to solve for. So I notice that this side, QR, is labeled as 16 inches. And then, of course, the question is, well, is 16 going to be H or is it going to be L? H stands for the hypotenuse, and if I carefully look, oh, QR is the side across from the 90 degrees. So that must mean that 16 inches is my hypotenuse, that's H. So what I'm solving for are the two congruent sides, and they're, of course, both L. So let's go ahead and substitute in. I'm going to substitute in 16 for H and write the rest of the equation is equal to L times the square root of 2. Now, I'm trying to solve for L, and L is being multiplied with the square root of 2. So in order to get rid of this square root of 2, I'm going to divide on both sides by the square root of 2. Because again, the operation here is multiplication. I'm not square rooting L, nor am I taking it to the second power. I'm not seeing L squared. I see L times the square root of 2. So to get rid of it, we need to do the opposite operation, which is to divide. All right, this allows me, of course, to cancel out my square root of 2's on the right side, and I'm left with 16 divided by the square root of 2, which is equal to L. We never leave our answers with square roots on the bottom, so we always need to make sure that we rationalize. So I have a separate video on rationalizing. I will go ahead and link it down in the description box below. So feel free to take a look at that if you need a refresher on how to rationalize. In the meantime, I'm just going to go and skip right to our final answer, which is L is equal to 8 times the square root of 2. And that, of course, is my final answer. We have solved for both missing sides because, again, they are congruent. All right, go ahead and pause the video here. See if you can give this one a try on your own. All right, go ahead and check over your answers. Notice how this time, after identifying my triangle and writing the equation down for the 45, 45, 90 triangle, when I went to go label my triangle, I noticed that, oh, here's my right angle, and right across from that is H, my hypotenuse. And I don't have anything labeled here this time. So that means that my legs are 4 meters. And when I substitute it in, keep in mind that I didn't actually need to solve for anything because H is already by itself on one side, right? H has already been solved for. So my final answer in an exact form is 4 times the square root of 2. And of course, the other missing side, HF, is also 4 meters, thanks to the fact that we know that these two sides are congruent. All right, here's our second triangle. This one can be a little bit trickier, but it's called, of course, the 30, 60, 90 triangle, thanks to the fact that you have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Now, this triangle has two relationships. Let's quickly talk about them. So in a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the short leg. So that's our first relationship. Let's quickly talk about that. Now, the question is, which leg is the short leg? I can always, of course, quickly identify my hypotenuse. It is across from the right angle. But now I have two legs to consider. I have the one up here and the one down here. One is going to be the short leg. The other, of course, will be the long leg. But here's what I look for. I take a look at 30 degrees. This is how I figure out which leg is short or long. The 30 degrees is smaller than the 60 degrees. So in the same way you pick out the hypotenuse, right? It's across from the 90-degree angle. The small or the short leg should be across from 30 degrees because it's the smallest side. So taking a look at 30 degrees and going right across the triangle all the way to the other side, this is the short leg, or S as we will call it. All right, so now that I have these two variables, let's write the equation. First equation, from number 1, it says that H, my hypotenuse, is 2 times as long as the short leg. So that's quite simply just 2 times S. Right? Okay, now the second relationship says that the long leg is square root of 3 times as long as the short leg as well. All right, so we can identify the long leg in the same way that we did for the short leg. It's just slightly different. Now, the short leg here is across from the 30-degree angle because the 30 degrees is the smallest angle, right? Because we have a 90-degree, we have a 60-degree. These two are very much larger than the 30 degrees. So if 30 degrees is the smallest angle, the side across from that must be the shortest or the smallest side. That's what we got S. So the longer leg, now keep in mind the long leg is not the hypotenuse. The hypotenuse is just simply the hypotenuse. We don't call it a leg. So the other leg, which is not the hypotenuse, and it's also across from the 60 degrees, is going to be the long leg. So for this one, yes, I'm going to go ahead and call it L again. But keep in mind that L here stands for long leg. Okay. All right, writing that equation, the second equation for our second statement, the long leg is the square root of 3 times the short leg. There we go. So these are the two equations that are associated with the 30, 60, 90 triangle. Notice how they both have the short leg in them. Okay. Now, a good question might be, how do I know which one to use out of these two equations? My answer is it depends on which sides are already given to you. So let's go ahead and take a look at an example to figure that out. Okay, let's go ahead and look at our second example, example 2. It still says to solve for the missing sides. Again, we have multiple missing sides. VW is unknown, as well as VT or side TV. They want us to give an exact answer. So, just like with the previous example, what I always want to do first is to identify the triangle to figure out what kind of triangle it is. So taking a look, I have here a 90 degrees. I also have a 60 degrees. And if I did some quick calculations, I could figure out, or if I just remembered, that my last angle has to be 30 degrees, which means that I have a 30, 60, 90 triangle. All right, so now that I know what kind of triangle this is, let's write down the equations associated with the 30, 60, 90 triangle. There are, of course, two equations. One is going to be H is equal to 2 times S. The other equation is going to be L is equal to S times the square root of 3. So we have three variables, H for hypotenuse, S for short leg or small leg, and L is for long leg. I always recommend that we find our hypotenuse first and label it on the triangle because it's always across from the 90 degrees. So if I can figure out where it is, I look straight across, and the side opposite or side across from that angle is side TV. That is going to be H, my hypotenuse. The next side that I always like to label first, next, is the 30 degrees. Now, if I compare 30 degrees to 60 and 90, this is the smallest angle. So if I look across from the smallest angle, I should of course have the smallest side or small leg. So let's go ahead and label VW or WV, which is across from 30 degrees, as S, which again stands for the short or small leg. By process of elimination, I know that the last side is L, but again, the longer leg, which is across from 60 degrees, this is the longer leg because 60 is greater than 30. It's really just that 60 is greater than 30, which means that this side, TW, which is across from 60, is longer than VW, which is across from 30. All right, so that then tells me that L is 12 feet. Again, L is the long leg. So now we can go ahead and figure out which equation to use. I'm given the long leg. I don't have the short leg or the hypotenuse. And so I look at my equations and I see that the one on the right side has L in it. So that's the one I'm going to use. It doesn't necessarily matter which order I solve this in. The order gets determined for me based on the equation that I'm going to use first. So let's substitute in. L is 12 feet. So 12 is equal to S times the square root of 3. Now, because this says S times the square root of 3, and because this is my variable that I'm trying to solve for, let's divide by the square root of 3 on both sides so that they cancel out on the right side. And I'm left with 12 divided by the square root of 3 is equal to S. Again, I need to rationalize, and you can check out that video if you need to. But I'm going to go ahead and skip that step and let you know that the rationalized answer is 4 times the square root of 3. That's my final answer for S, the short leg. So what I'll do now is I can go ahead and take S and substitute it in because I know what it is now. So H is equal to 2 times 4 times the square root of 3. Here, though, I have to be careful. I cannot combine 2 and the square root of 3 and call that the square root of 6. And technically, I cannot do the same thing here and say that 4 times the square root of 3 is the square root of 12. These numbers, the square root numbers, are different kinds of numbers. So if I wanted to multiply them with other numbers, they both have to have the square root. Because 2 and 4 do not have the square roots, I cannot combine them. But I can multiply them with each other because they're both whole numbers. So what I get for H is 8 times the square root of 3. And that right there is the other missing side. So I solved for H, it's 8 times the square root of 3. And I solved for S, which is 4 times the square root of 3. All right, go ahead and pause the video here. See if you can give this one a try on your own. All right, go ahead and check over your answers. Once more, after I identified that this was a 30, 60, 90 triangle, I went ahead and wrote down both equations. I separated them a little bit differently here. One's on the left, one's on the right. And then you don't need to, but I love doing it. And that is to fill in all of my missing angles, because this helps me to clearly see and identify the different sides. So here's the 90 degrees. Right across from that is the hypotenuse. Going on to the 30 degrees, across from the smallest angle is the smallest side. So that side was labeled as S. And then, of course, the longer side, or the longer leg, is across from the 60 degrees. And then from there, because I was given the hypotenuse, this led me to choose H is equal to 2 times S as the first equation. Solve for S, substitute in. And here, because it's just 4 times the square root of 3 and L is already by itself, I can go ahead and stop here, and this is my final answer. All right, so that's it for this video. Thank you so much for watching.